Welcome to Lesson 2. In this lesson we're going to talk about electrostatic discharge. Now, why are we even talking about this early in the course? Let me tell you. The reason is because electrostatic discharge can destroy computer components. I've had it happen to me and it's no fun because it usually happens when you're trying to fix some other problem. You have an electrostatic discharge and you blow up some other components and you can't figure out what the heck is wrong with your computer. Okay? So we're going to talk about this right up front. We're going to talk about two things. Number one, what is electrostatic discharge? What causes it, in other words. Second of all, what are some things you can do as a computer tech to minimize the risk of damage to your computer, electrostatic discharge? So let's talk about the very first one. What is electrostatic discharge? Electrostatic discharge occurs when there's a flow of electrons from an object with high electrical potential to an object with low electrical potential. How does that situation occur? Well, when two objects come together and then are subsequently separated, if the materials are right and the conditions are right, sometimes the one object will strip electrons from the atoms of the other object. When that happens, this object over here that took electrons now has a high negative charge. And the object over here that lost electrons has a positive charge. If that happens over and over and over, this object over here that's taking electrons can develop quite an electrical potential. That happens to you when you walk across a carpeted floor in like wool socks. Every time you take a step, you're stripping electrons out of the carpet and you build up a very high electrical charge in you. And then you've got electrons singing inside you. You've got so much electrical potential. Now, that is not ESD yet. That's just building up the charge. ESD occurs when you reach out and touch something that has a lower electrical potential. When you get close enough, the electrical potential tries to even itself out by discharging into the object that has the lower potential. When that happens, a shock can occur. Now, why is this of concern to you? Why do we care about that for working on computers? Because it destroys components, as I said before. And to give you an idea of how little discharge it takes to destroy a component, remember this. A computer component can be harmed or even destroyed by an electrical discharge of less than 100 volts. In fact, you can damage a component by as little as 20 or 30 volt discharge. With electrostatic discharge, it takes 2,000 to 3,000 volts of discharge before you can feel it. That means that you could be damaging or destroying an electrical component and you don't know it. So you need to take proper precautions to prevent electrostatic discharge from occurring. Now that we understand what electrostatic discharge is, let's talk about our second objective, and that is some things that you can do as a computer tech to minimize the risk from electrostatic discharge. Rule number one, and the foremost rule, always ground yourself to the computer equipment that you're working on. The reason is, when you're grounded, there's no difference in potential that builds up. Any charge that might build up on you or on the computer is immediately dissipated, and by doing that, an equilibrium is maintained between you and the component, therefore no static discharge can occur. Now, as a computer tech, you should always use a static mat, like this blue one I have before me, to work on your computer components. It has a conductive surface that dissipates static discharge buildups. And it also has some leads that I can connect to the computer and to myself to make sure that our electrical potential remains the same. I'm going to show you how to use that here. I've happened to have a computer case that I need to do some work on. Set this right here. Okay, so it's on the static mat, and to equalize the electrical potential between me and the computer chassis, I'm going to take this lead and connect it to the chassis. And then I'm going to take this wristband, which you notice right here has a conductive surface that touches my skin. And by doing that, it establishes connectivity between me and the mat, and between the mat and the chassis. So I just slide that on. At this point, I am now grounded to this computer, and there can be no static charge build up on either side of it because we're always dissipating our charge between each other through the mat. Now the question arises then, whether or not I should have this computer case plugged in while I'm working on it. There'll be those who will argue that you should because it creates a perfect ground. I disagree, and the CompTIA folks disagree as well. do not have this case plugged in while you're working on it. And I think the reasons are fairly obvious. If I'm working on this computer case, I do not want to be plugged into a 110 volt outlet. If something should go wrong in the power supply and connectivity is created between the case and the 110 volt side of the power supply, I don't want to be touching to it, nor do I want to be tied into it with a wristband. Okay? So do not plug in the computer case while you're working on it. Now there will also be times when you're out in the field and lo and behold you don't have a static mat to ground yourself to while you're working on a computer component. That will happen all the time, I promise you. There's a way to do it without all this fancy equipment, and that is, instead of using these clips to ground yourself to a mat, all you have to do is just maintain contact with the case at all times while you're working on it. It accomplishes the same thing that the static mat does, and that is maintain an equilibrium in the electrical potential between you and the case. So if you're working on it, you just keep your hands on it at all times, and you don't have to be touching it all over the place, just a little bit here and there, just to make sure that any charge that builds up is dissipated between you and the case. That way no electrostatic discharge can occur. Rule number 2, never touch the leads on an expansion board. As you can see right here, I have an expansion board. This happens to be an audio card. Along here are a series of leads that are used to connect it to the motherboard. The reason I don't want to touch any of these leads is simply because they are direct electrical pathways into the various circuitry and components that make up the soundboard. If I have a static charge build up on me and I reach down and I touch one of those leads, I just shot a very high voltage discharge right into the componentry and the circuitry here on the board. So remember rule number 2, don't touch any of these leads. Rule number 3, always store your components in static bags. I have a sample of a static bag right here. It looks just like a regular old Mylar bag. However, it has a special surface coating on it that dissipates any static discharges. That means I can put in a component inside this bag, I can build up a real zinger of an electric charge, reach down and touch this bag, and have a discharge actually occur. However, the charge will be dissipated through the coating on the bag instead of going through and actually hurting the component that's inside the bag. Now, it's important to note that there are many different types of static bags. This that I have here that has the silvery tint to it is the best you can get. This is called a static shielding bag. This will protect a component on the inside really well. There are other types of static bags, however. Sometimes you'll see a pink one such as this, or maybe a blue one. These are called anti-static bags. Now they will work, but they don't work as well. They act more as an insulator rather than a dissipator. They will work, they will protect your components to an extent. However, strongly recommend that you keep your components in a Mylar type bag that looks like this with the silver coating on it. To protect your components, all you have to do is slide them inside the bag, fold it over, apply a little adhesive, and that component is now safe from electrostatic discharge. This is really important, especially if you're going to be transporting it somewhere. Say you put it in a box and you drive around and you pull it out of this box and you hand it to somebody. The chances of a discharge are really, really high. So I strongly recommend you use these, especially when you're transporting it or sending something through the mail. Rule number 4, always keep sources of static away from computer components. Now, the two big culprits that I've experienced with this are styrofoam and plastic. I have a sample here of some packing peanuts. These can build up a massive static charge in you just by touching them. Rule number 5 is kind of a hard one. It's a good idea, it may not always be possible. And that is, try to keep the humidity in your work areas at about 70% or higher. And the reason for that is that the humidity dampens the static discharge. That may not always be possible, especially if you're working in the field. But if you have a workshop or someplace like that where you're doing a lot of work on computer components, buy a humidifier and increase the humidity in the room. That ends lesson 2. In this lesson we talked about number 1, what causes electrostatic discharge, number 2, what are some steps that you can take as a computer technician to minimize the risk of damage to your computer components from electrostatic discharge.